All right, welcome back. I'm getting some great support and feedback on this LPIC series I'm doing, so I'm going to keep on going with that. All right, so last video, it looks like it was a part 1 of this 103.4 lesson 2. This time around, oh, yep, it looks like we're going to go to the guided exercises. I'm not sure what happened here with this text string. It looks like it's not highlighting it correctly, so I'm just going to quick take care of that. And we could ask ChatGPT. I love it so much. Is that the correct series of strings for entering a Chrome URL to highlight some text in the page?
The feature to highlight text in a Chrome URL is generally accomplished using the hash tilde text equals fragment. For instance, if you want to highlight the word example on a web page, you'd append hash tilde text equals example to the end of the URL.
Yeah, so like I thought that's what I did, right? Oh, it's not. I did a dash, not a tilde. Oh, and I didn't even do. Oh, I did an equal sign there, I think. Let me see. I'll do a Control Z, or I'll just open it up again. So I did pound sign, colon, then TXT, then pound sign, then equals. But the real thing is pound sign, colon, tilde, colon, text equals. So I got it completely wrong. All right, so we're going to do the guided exercises. It's convenient to save the execution date of actions performed by automated scripts. The command date, and then there's the date format, shows the current date in year, month, day format. How can the output of such a command be stored in a shell variable called today using command substitution? So I remember this. This was actually kind of pretty groundbreaking for me. There was a lot of learning happening. Oops, so I can just type lab now. So here's the answer. So let's see here. Now if I just do date and just type it all out. Okay, so now we get the date back, but you know this is what we talked about all in the last video. Might have been the video before that, but this is standard output. So we run that command date, and then we feed it that input to the command. It's not standard input; it's input fed to the command, and then we get back standard output to our bash screen. Okay, so what we could do instead is we can feed in standard input with these backslash. So with these backslash characters, we can tell this date command, instead of returning standard output, return standard input. There we go. So now this was sent to the bash prompt as input instead of output. So now instead of just displaying it, it's input. So it was input to the bash prompt as if we were doing this, and you can see we got the same standard output. As a result of that, this command is not found. So yeah, hopefully that's all I need to explain for that. So now that I've proven that you can convert standard output to standard input, how can the output of such a command be stored in a shell variable? Well, just like this. So if we do today equals, now we need to feed input to this in order to define this variable. If we feed output, it's not going to work. So this is how we feed input. So now let's do an echo, or let's just do today like that. I think we might need to do echo. I'm not sure. That's why I want to do it. Okay. Well, let's do this. Let's do this. Echo. There you go. So yeah, now if we echo the today, we get standard output here, and everything is happy go lucky. All right. So let's see what the real answer is. All right, so the real answer is everything I did. I forgot to mention this, so let's just type that out because it could be useful for scripting or whatever. If it's, sometimes it's easier to use a different syntax if you're writing a script. And just by nature of it being Linux, there's always more than one way to do something, so let's learn them both. Date. So same thing, we're feeding it the same format, but now we're going to get back standard input instead of standard output. And because it is input and not output, we can feed it to something that takes input, such as the definition of a variable. There we go. And let's change up this syntax a little bit so we can see that it actually does change. And to call a variable, you need this syntax here. And there we go. We did change the variable. All right, so on to the next one. Using command echo, how can the contents of variable today be sent to the standard input of the command sed? Okay, so that's interesting. So let's take a look at the sed help. So --help. So now we got options, and there we go. Here's the input. So we need to feed the output of this variable into sed as input to it. So I believe the way you do that, because the pipe command looks like this. So using the command echo. So what we're going to do is we're going to take the output of the command echo for this today variable, which we see here. I'm going to set the variable back to so that it matches the answer. But we can now see here, this is standard output. So what does the pipe key do? So what the pipe key does is it takes the standard output from the command to the left, converts it to standard input, and feeds it to the command on the right. So we saw the syntax for sed. It's sed, and then you define some options. So we're going to do that here. And then you feed it standard input. And we're already doing that by way of piping the output from the echo command into the sed command as standard input. And there we go. Now we converted the dashes to the dots. I'll do one more thing to prove that this is in fact standard input. So I didn't feed it anything for standard input. So what does it do? Well, it seems like it's just hanging and working. Don't be fooled by that. What it's doing is it's collecting standard input from your keyboard, and then it's printing out the standard input as standard output. So if I do line 1 like this, now I've got standard output, and the standard output is the input that came from my keyboard, since we didn't specify where the input would come from otherwise, unlike we did here where we piped in the output from the echo command as input to the sed command. So now if I feed it something like this, now it matches on that. So we get here. So I'm done feeding it standard input from my keyboard. So I'm going to hit Control C. That universally stops programs like that. And now let's take a look at the answer for this second guided exercise. Okay, so yeah, it's the exact same thing I did. What the pipe command does, and it's easy to get confused. And this is one of those things too, where like when you are just learning it Bohemian style, just doing what you do to make things work, you're going to mess this up all the time. You're not going to understand which side to put each command on. Do you put SED to the left? Do you put echo to the left? You know, you don't know what pipe actually does. You just know that when you use it, you get favorable outcomes some of the time, unless you swap the sides they're meant to be on. So now you can always remember which side is meant to be on, because the left side is the side whose standard output is converted to standard input and plugged into the command on the right side. So of course it's not going to work to have SED here, because SED won't even provide you with standard output unless it gets input. So let's prove that. I'm going to try to pipe the standard output of SED into the standard input of today, which already has standard input, or not standard input, but it already has input. So yeah, we can see this we don't have any standard input. It's just you know, it runs all the commands at once too. So like it ran the hello command. Yeah, now if I hit just gobbledygook, if I hit line 1, you know, it's finished running this command already. I tried to pipe the standard input over as standard output. The standard input was nothing, so it piped nothing to it, and it just echoed out the variable. So there you go. That's how you can remember when you do a pipe which command goes on the left and which command goes on the right. From left to right, it's the output of the command converted to the input and then passed into the command across the pipe. All right, so number 3, how could the output of the command that we used earlier be used as a here string to this command? So I believe the answer is this. All right. But nope, this is not correct. SED cannot read this, no such file or directory. So maybe if we wrap it in quotes. Okay, so that's probably not it either. What if we convert it from output to input? Okay, so if we convert it from output to input, now it does work to do it this way. Let's see if that's the answer. I have a feeling it's not. Okay, so this is the answer. So you do it by converting, and it looks like they have a space there. From what I understood, a space is typically not the best thing to include after redirects or here string conversions, because sometimes this space is actually part of what happens as a result of these symbols. So I'm kind of surprised that they included a space there, but maybe for a here string, it's fine. But yeah, there we go. So I got the same answer as they did. Of course, there's the other syntax. I'm not going to type that out because it's pretty self-explanatory. All right, so the fourth guided exercise. Command convert image.jpg -resize 25% small-image.jpg creates a smaller version of image.jpg and replaces the resulting image in a likewise named file inside subdirectory small. Using xargs, how is it possible to perform the same command for every image listed in the file list.txt? All right, so let's make that file image.txt. So we're gonna do vi file list.txt insert mode. Now they've got image.jpg. Oh. Okay, so yeah, so here I'm understanding the question better now. So this is the command convert, and then here they're just specifying a file to convert. But the final question is, how is it possible to perform the same command for every image listed in a file? So for our answer, we're not going to feed a specific image. We're going to feed it a file and have it go through each of the images in the file. So I'll create that right now. So we've got image, then we'll have image 1. Okay, and then image 2, then image 3, image 4, and image 5 for a total of 6 images. All right, now I will write that and we'll take a look at it. Yep, file list.txt right there. So this is the command to create a smaller version of this with just without one file. So okay, xargs. Let's do a help on xargs just to refresh my memory, or a man on it. Okay, so we can build and execute. Okay, so this is what we need to do. We need to do something like cat on file list.txt. Okay, so now that's standard output, but that's not what we want. We want standard input. So what we could do is we could pipe the standard output as standard input, and we can do it to so we can do xargs. And then convert. Now I'm not sure what you do here, and I'm not even sure if this is the right way. Let's see if we can get some more help on xargs. Okay, so run the command with arguments initial xargs and more arguments read from input. So let's take a look at the man page. We'll probably get like everything we need to know is at the top here. Yeah, examples. So like here's an example. So this is a command kind of like our convert command, but the input we're feeding to the command is /tmp, and then interesting. So this example finds files named core in or below the directory /tmp and then deletes them. So here we go, finding something named core. The directory is searching through. And now we've got a type, which means we're not going to delete any directories. We're going to delete files. And then we've got a -print, which I'm not too sure what that is. Ugh. All right. So, Okay. You know what? I'll just try it. If I don't get it right on the first try, and I have to look at the answer key, then so be it. So I'm not sure. The thing is, like, if you cat out this, like, the standard input is this whole thing. It's not like Python where it's a dictionary and you can loop through it all. This is just one piece of standard output. So if you convert this whole thing to standard input, I think this is what you're passing to the command, and I'm not sure the command can process this. But let's try it that way anyway. So we're going to take the standard output there, and then we're going to feed it into convert as standard input. Oh, and here's where it's tricky too, because it's like, what? We don't even have convert to. Oh, I've misspelled it. Okay. Oh, still don't have it. Yep, and here's the image magic that they were talking about. So I need to get that on my home lab, which I guess I could do. I'm gonna do that because I think they're gonna be using those kinds of commands all throughout the learning materials. So, as we saw in the last video, I do have limited space in my lab, perhaps less limited now. And that was in my video from my other series on automate your network. One of my disk partitions, like the main one where I should be saving everything, all my regular files, wasn't mounted, so like I wasn't oh my god, sorry, I work right by the window and I see everything that happens outside the window. There's something happening outside the window right now. But anyways, let's keep on going. So command, it's no big deal. It's just let's keep on going. It's really kind of rude for me to look at. So I'm gonna be looking away. Especially for me to like call out on a stream, because it's just like somebody's obese, and like, who am I to judge? I'm having issues with weight as well, but it's just kind of sad sometimes, because it's like, it's a real health issue. But anyway, okay, so I tried that, and so now we have the command, so we can actually run convert. Let's get a help on it. There we go. There's all the documentation for it. So let's try it again. And we've got no images detected, no images defined. So let's define one. We're going to define image. .jpg, JPEG. And we've got the same problem. No images defined. So I'm not sure if we need to create. Okay, so I'm not sure if we need to create that directory first. I'll try that. Okay, so same problem here. We do get this special. Oh, it's just word wrapping. So yeah, same problem there. That's I thought that wasn't going to be the way to do it. And then not only that, I forgot xargs. So let's just try it again with xargs. Okay, so now this is encouraging, because we've got 1, 2, 3, 4, 5. Oh, okay, we've got 7. That's interesting. Oh, but so okay. So what if I try this? Okay, so now we've only got 6, but this is encouraging. You can see it's doing it for each line of standard output in this file. It's not just trying to plug in one large image name for one image. It's plugging it in 6 separate times, which is good. So the only part I'm not sure about now is how do we get it so that it plugs it into this here and it creates a new file for each of those. So let's get some help on xargs. All right, so there we go. So now we were able to okay. So we definitely don't want this because we're feeding it the standard input. Okay, so yeah, I'm not sure what to do here. Let's look at the man for xargs because there were some interesting examples given. So, okay, core in or below. So here's just the command given. So I think we need to feed. Okay. Yeah, you know what? I think I do have them flipped. Um, so we need to feed the. So how can the output be stored in a? So yeah, how can the output of? Oh no, here's the one we're at, and I'll control find it so that it's yep, and that'll take us to the answer. So I think I did get it backwards. We want to feed in the standard output as input to xargs. So like this to this command. So it's like the command is remove-f, and then each line of standard output from this command will get piped over to this command. So we did have the order correct. I do understand that, but we need to have it go here. So you know what? Let's just look at the answer. I feel like I'm close enough. Okay, so this is the answer here. So, okay. So you know what? I wasn't. I actually was kind of close enough. So, all right. So let's take a look at what the answer is and what I had. So here's kind of like my main answer. So, yep, I got that right. We're gonna take the standard output from catting out this file, and we're going to feed it into here as standard input. Xargs automatically makes it so that the standard output is converted to standard input, and it's fed to the command one at a time. So now what we're doing is we're doing -i. So let's take a look at the -i help. All right, and I'm wrapping the grep pattern in quotes. Oops. Okay, that didn't work. Let's just do. Usually, help menus aren't that large. Where grepping makes a lot of sense. Okay, and then uppercase I. This is the same as replace. So what we're gonna do is so same as -- replace equals R. So these are the same commands. Replace R in initial args with names read from standard input. Okay, so there we go. Oh, okay, and this is how we. So this is with with names from the standard input. So wait, I'm confused. Ah, okay. Now it makes sense to me a lot. Okay, now it really makes sense to me. So let's think in terms of Python, because Python I'm really comfortable with. Hopefully, people watching this channel have some familiarity with Python to the point where this will make a lot of sense. So I've got Python 3. Let's define a variable. Say we'll call it aha, like that, and then we're going to do what is called an f string. So an f string is just a string where you can fill in variables. So I can say hello world. So I can here. I'll explain an f string. So an f string works like this. We're going to define a variable named hello, and then the variable is going to be a string with hello like that with an uppercase h. So if we do a type on the variable hello, we can see that it is a class, and it's a string class. It's an object. Everything in Python is an object, which is a class. So, and then we're going to define world as WRLD uppercase. All right, now let's write out an f string. So we're going to say we're going to say it equals. Now there's the f string. And this is how f strings work. You do these squiggly characters. These are special characters. Then you type in whatever the heck you want to be in that string. I just want there to be a single space. And then in between each of these squiggles, you can put the whole variable names without any other sort of syntax, without converting it from a familiar with Python, and if you run into that, you know, it's not a string type, it's an integer type, it's a float type, you know, it's a list, it's a dictionary type. You can't print it out until you convert it. Well, not anymore with f strings. That's a part of what an f string does. It automatically converts the variable to a usable format. All right, so we've converted we saved the say it to an f string. So now let's print out the f string. Well, first let's do a type on say it. I love doing types. I love doing these like little checks to like get yourself, you know, if this would turn out as like an integer or a list or so, you know, something's wrong. So like just to kind of keep your mind attached, your head attached to your body, like, you know, it's nice to get these little checks in there. So before you veer off too far in the wrong direction, you can kind of stop yourself and rethink it. So it is a string. So let's print it out, say it. And there it is, the classic hello world that everyone learning programming does for the first time. And we can notice that this space is reserved. We can notice that the actual definitions are used and not here. So it's not printing everything out in lowercase, and it's not leaving off this exclamation point because it's calling these variables here. So how is this relevant to what we're doing here? Because this is what we do. We're defining a f string basically. So we've got our string here, and now we're plugging in these variable names, img, which we defined here. We defined our variable here as capital I, capital M, and capital G, and then in what is similar to an f string in Python, but you know, this is not Python, this is Bash. We plugged these in, you know, in the same way we plugged it in here. So this is kind of how I thought it would work, but you know, I wasn't really able or willing to think all the way through. So what we do is we do the xargs command, and then we define this variable. Then we do the command we actually want to do. And then we say this is basically like an f string, and then we plug in here input that we get from the xargs. And then the input is the standard output from this command converted to standard input via the pipe, and then fed line by line into this ximage variable. So one thing we can do is cat file list.txt pipe xargs -i, and now we can feed it into the echo command. Echo img. Oh, sorry, we've got to define this. Now we can define it as anything we want. ASDF and we can do echo ASDF. Now, what are we gonna echo here? Are we going to echo ASDF? No, we're gonna echo each of the lines in this file, because we defined a ASDF as a variable. So basically, we're doing the equivalent of this. But since it's a part of xargs, we don't have to include this as if it were a part of bash. This is the xargs program we're dealing with, not bash in this case. It's run in bash, but it's a custom defined program. So yeah, we're not echoing out ASDF, the way we would be if we were entering this here in bash. We're echoing out what this variable that we defined here is filled in with, and it's filled in with standard input that came from using the pipe key to convert the standard output of this cat command. So there we go. I'll try the full command just for kicks and giggles, but it might not work. Yeah, okay, yeah, it doesn't work. I think this is proof enough right here, this echo, and I feel like this really demonstrates well that this kind of works like a Python F string, which might be hard to pick up on. So if anyone is watching it, made it this far, studying the LPIC, go learn some basic Python, because then you can do things like this. You can cross-reference concepts, and if it doesn't really make sense here, you can do something where like it really clicks and makes sense to you in Python, and you can think about like how the two concepts are similar and like how they're different, and that should help a lot with comprehension. All right, so on to the explorational exercises. Let's see what the clock says. The clock says about halfway through. That's perfect. All right, explorational exercise number 1. A simple backup routine periodically creates an image of partition. So that's /dev/SDA1 with dd. Not familiar with that command. So dd command is copy a file, converting and formatting according to the operands. So we plug in an operand to it. So we can do bytes, we can convert the file to a different file type. Okay, so a simple backup routine periodically creates an image of that partition with that command to perform future data integrity checks. The routine also creates a SHA-1 hash of the file with SHA-1 sum, and then that's the I think we're so it's not the redirect character, it's the other way. So I think you're feeding the standard input of SDA1.img to SHA-sum, and then that standard output you're redirecting into that file name. By adding pipes and command T, how would these two commands be combined into one? Perfect. So this is a good one. So we're going to combine both of these commands into one. The first command is this dd command here, and I'll just try running that. Permission denied. Perfect. That's kind of what I'm looking for. I don't want to actually run it. And then we'll run this command here, and same thing. This is not real life. It's just part of the lab. Just part of the lab exercise, so don't have those, that's fine, we won't create them. So now what we're going to do is add pipes and use the command T. So what the command T does is it, you can think of it like a golf tee. The input and the output, so it converts, it's kind of like these, it converts the input to the output. So it's like when you swing your club, that's input to the ball, and then when the ball flies down the golf course, that's output. So T does that. It takes the standard input and it converts it to the standard output, which is useful because sometimes you want to see the standard input, and in order to see it, you have to convert it to standard output because standard input and standard output are not the same things, and they don't display in the same way. Okay, so to perform, so by adding pipes and using Command T, we can combine the two commands into one like this. So what we want to do is we want to take, so what we're doing is we're generating a SHA-1 hash file, and we're doing that after we create an image of the partition. So this is what we do to create the image of the partition. So now that we have that image of the partition and we have a standard output for that's interesting. So we don't have standard output because we're redirecting the standard output into this file. So we're not converting standard output into standard input in this file. Okay. Combine them into one. Okay. So we definitely need a pipe between the two commands. As far as which command to go first, the one you'd want first is the command whose standard output you want to convert into standard input and feed into the second command. So let's think about which command you'd want to do that. So it's this command, because you want the standard output of this command to be, so first of all, it is redirected. But I'm not sure if let's do this. So we're gonna do we're gonna do echo hello world, and then we're gonna redirect that into a file called hello.txt, and then we're gonna pipe out, and I'm gonna fix my fat finger there. We're gonna pipe it out and feed this hello world into another echo command. Okay, and you can see the reason this didn't work is because we're converting the standard output into standard input, and then we're plugging it into this command. But we don't have any standard output because we redirected it to the file, so the pipe can't see it. If I were to take the file away, okay, I do not have a clear understanding of it. See, this is why you got to constantly experiment and check, and like if you're coming to a conclusion, just do a simple quick check, and you'll see whether or not your conclusion is correct. So the standard output of this echo command is hello world. So I thought what I was doing is converting it to input and then doing it here, so we would see this show up here. But obviously there's some flaw in my understanding. Okay. So you know what we can do, and I love this so much. Let's ask the AI. Like, this is where, to be a modern person working in technology, you got to start using these tools, because otherwise you just, you're going to be, people are 10xing, 100xing, 1000xing. You can see that with me too. I learn a lot more when I use the AI. So let's ask the AI. So in the above example, what I thought would happen was the standard output from the first echo command would be converted by the pipe into standard input and then passed by the pipe into the second echo command. So what I thought would happen is you would see the hello world statement printed out to the screen as standard output. And you can see that I tested whether or not this would be true by removing the redirect. I thought that since I redirected the standard output into a file, it could not be converted to standard input and sent to the second echo command. But when I did both things, and it did not seem to matter that I redirected it or not, both times I got blank for my standard output. Why is this the case? Was my understanding of what the pipe key does incorrect?
The echo command in Unix, Linux is typically used to display output to the console. However, when used as part of a pipeline, it would receive the output from the preceding command as its standard input.
Yes.
That's the general idea behind pipes. To take the output of one command and use it as the input to another.
Yes.
In Unix-like environments, the echo command doesn't read from its standard input, but from the arguments provided it. So, when you pipe something into echo, that data essentially gets ignored, because echo is not designed to read from its standard input.
Oh, okay.
Consider this example. In this case, the second echo command does not read from standard input, it just prints something else as standard output, ignoring whatever was piped into it.
Oh,
Also,
okay.
file redirection, greater than, has a different purpose. It redirects the standard output to a file. In the case of your pipeline involving echo, the standard output of the first echo was successfully piped into the second echo command. However, the second echo didn't read it, because it doesn't read from standard input, and that's why you saw a blank output.
Oh, okay. So, okay. You know what? Let me try this. Ah, okay. So now we got it because T. Let's do another dash on that. So what T does is it copies the standard input to a file, a command, whatever you would like. So that okay, this is actually pretty like powerful. So I understood the pipe key exactly right, but what I didn't understand was the echo key. The echo key does not handle standard input. It only handles input from commands. So if I were to do echo, notice how this is different. I typed echo, I typed enter, and what happened? It gave me my prompt back. So let me type something else. Let me type WC. I don't have my prompt back because this counts the words in the standard. This takes standard input. So it's taking standard input is what it's doing right now. It's waiting for me to provide it input, like, for example, keystrokes from my keyboard. Echo doesn't take standard input. What Echo does is it echoes out any input fed to Echo after the echo command. I did not feed any input to echo. So that's what we got. We got back blank because we fed it blank. Echo does not take standard input, and that's different from commands like WC that do take standard input. When you run WC, it doesn't count and return 0 because I fed it blank. You have to give WC input, whether from whatever source. And if you don't give it input, then it collects it from standard input, so your keystrokes. So you don't get that prompt back right away. So hopefully that makes sense. So I had everything right, and this is, this takes us to what is T. So what T does is this standard input is now converted to standard output. So now we're not feeding standard input to Echo anymore. We're feeding output to it, and Echo can handle output. You can feed it variables, and it will do out the variables. So it was just a matter of the output command. So my final answer for this would be we take and it's for the explorational exercise. All right, so my final answer for this would be we take the first command, then we do a pipe T, and that will convert the output of this command, which is now the thing is, let's test my understanding about the redirect. So we got to enter T in here now. Aha! So I was right. The output is in this file. It's no longer. So now this doesn't have any standard output that you could redirect. That you could convert standard input using the pipe, because the standard output is sent somewhere else and it doesn't. It's not there for the pipe to do things on. So that makes it a lot trickier. Huh. Yeah, this is a tricky one. Like, what makes it tricky is this second here, because when we run this, we won't have. So I guess what we could do is, maybe we could use xargs. I don't know. Let's just look at the answer. Okay. So now, yep. So this is what I was thinking. So wait, but it's no longer. It's only redirecting one of them now. Does it create this file? Let's look at the help for T again. Oh. So, I see. So you can. Okay, so what it does is it takes the standard input of the command, it saves it to the file, and then it also sends it to the standard output. So I just had an incorrect understanding of what T actually did. If we go back to the example here, so what we can do now is wait, but how is it not? Wait, is it? Oh, it is. Yeah, so we see this here. This is a file, and it will contain the standard input, which we have no standard input, because the standard input is the converted standard output, which we redirected. So yeah, that's a blank file. But now let's do this. Oops. Okay, now we're no longer directing that. So there we go. It's printed out to the screen, and now it's in that file. So hopefully this makes sense. The T not only converts the standard input to the standard output, thereby displaying it on the screen, it also saves the standard output to a file. And in fact, let's do this. We're going to say test 1 2 3. So yep, same thing happens. So in fact, we didn't do this echo command. This is just the equivalent of doing this. So if I cat out test 1 2 3, now we have it. So we weren't doing the echo command at all. We were feeding a series of strings, a series of letters to the T command. This was not being processed as the echo command at all this whole time. Okay, so now this makes a lot more sense to me. We're taking the command here and feeding to the command the standard output or the contents of this. So like the standard output of this, we're converting into standard input and inputting it to this command, I believe. I'm actually not certain about that. Okay. I kind of forget what this one does. So let's ask the AI. Okay, so the less than symbol is used for input redirection. So it takes a file as an argument and then feeds its content into the input of the command. There we go. So let me ask you one more question. Is the file that is fed as an argument using the less than symbol, is the content of that file standard output that is converted to standard input?
File content isn't treated as standard output when you use the less than symbol for input redirection. Rather, the content of the file specified after the less than symbol is directly fed into the standard input, stdin.
Okay, so that's kind of important to know. I think it's a little bit different from the pipe in that way. So, it's like if I were to cat out a file, cat hello.txt, we're using cat. We're giving input to cat here. This is just what cat does, but another way we can give input to cat is to redirect the contents of the file as input, and then we're not converting anything. We're just, this is the same thing. Okay, so this makes sense to me now. So we've got these two combined in the first command. Here, when they were separate, what we did is we took the contents of this and then we fed it into this as input, and then we redirected the output to this file. Now that they're combined, we're still taking the contents of this and sending it to here as input, but now instead of redirecting it, we're using this T, and what T does is it takes the input, and the input is the converted output by way of this pipe. So it takes the output of this command, convert it to input, and saves the input into this file. And then it also has output from here. And lucky for us, we've got another pipe, so we can take that output, we can convert it to input, and then we can plug it in here. So now that we've got this, and it'd be nice if we had like xargs, we can make that like f string. That would be a lot more clear, I think, in my opinion, but it's not that unclear. SHA-SUM takes standard input if nothing's specified, so where you would enter it and have to plug in standard input. Now the standard input doesn't come from the keyboard anymore, it comes from this prior command. And now we're redirecting it into that file. So there we go. That's the answer to that. And it makes sense to me. Hopefully it makes sense to you. All right. So the next explorational exercise is number 2. Command tar is used to archive many files into a single file, preserving directory structure. Option -uppercase T allows to specify a file containing the paths to be archived. For example, find /etc -type f pipe tar -lowercase c uppercase j -f, and then I'm sure there's a space, /srv /backup /etc.tar.xz -uppercase T dash, in this case the dash is standing for standard input, creates a compressed let me check my knowledge on that. In the case of this command, does the final dash mean standard input?
Many Unix, Linux commands, the dash used as an argument usually signifies that the command should read from standard input, stdin, rather than from file. However, this is not a universal standard. It depends on how the specific command interprets the...
Yeah, but in this case, it is the case. Got it. All right, so it creates a compressed tar file from etc.tar.xz from the list provided by command find option dash uppercase dash indicates the standard input as the path list. In order to avoid possible parsing errors due to paths containing spaces, what command options should be present for find and tar? So I believe it's dash print 0, and that's my final answer. Yes, I was right. Oh, but actually I wasn't completely right. So you also have to do null. So let's ask this. How come for the find command you need to use print 0, but for the tar command you need to use null? Why can't you use either print 0 or null for both commands?
B. Find and tar commands come from different origins and were created with different purposes and design philosophies. That's why they use different flags or options for similar functionalities. Let's delve into each command. Find print 0 option. The find command uses print 0 to print each file name terminated by a null character, 0, instead of a new line. This is helpful when you're working with file names that contain spaces, new lines, or other special characters. The print 0 option ensures that each file name is distinctly separated, even if the file name contains unusual characters. Bash copy code bind. Type fprint 0 tars null option. The tar command uses the null option to signify that the input file names it receives are separated by a null character, 0. This is useful when you're piping in a list of files from find print 0. Bash copy code bind. Type fprint 0 tar czdf archive. Tar. GZ, null T. The difference in flag names, print 0 for find and null for tar, is essentially a result of historical development and the absence of a universal standard that mandates how flags should be named across different commands.
That sucks.
Learning the specific flags and options for various commands will not only make you more proficient in Unix, Linux, but could also be useful for your career objectives. Given your goals, especially the NCORE Cisco exam.
All right, so it just depends on like the command. So you can probably do a help on each command to determine which one it takes. So if we do find dash dash help, let's do a pipe grep print. Just print. Okay, so now we've got under actions print 0. So I think that's right. It's hard to tell because it word wraps. Oh, here we go down here, options. So yep, print 0. So what print 0 means is to it means that the space is a separation. So it means not to include the space basically, and to use that as a separation between the commands. So if we were to include that, we would be feeding a space to this next command. Here we're not doing that. And then dash dash null does the same thing, but because this is very, very early computer science we're talking about here, there's no standardization. So like they're the same command, they do the same thing, but they're just written in different ways because they're written by different people. You know, I think the way things tend to evolve over time, especially technology things, is you get more and more and more people, you know, working on the same things. And like there's a point where, yes, at the beginning Bob and Ted can each write their own things, and Bob can use dash print 0 and Ted can use dash dash null, and everyone's happy. But when Bob, Ted, Bill, Mary, trying to think of some names that are you know, when there's different people working on it, they have to know, you know, there has to be more standardization, because especially as things grow, you're writing more and more commands. There's too much to get wrong if you don't have standardization. So here's dash dash null, same thing as it does for dash print 0. Alright, so next one, instead of opening a new remote shell session, command SSH can just execute a command indicated as its argument. So execute. Oh, really? I didn't know that. Oh, no, I did know this. Okay, so what you can do with SSH, and this is great for automation too, but you can tell SSH to log in and hold a persistent, connection somewhere. Or you can tell it to log in, run a command, and log out. So given that SSH also allows to redirect the standard output of a local program to the standard input of the remote program, how would the cat command pipe a local file? Wow, okay, this is fascinating. Named etc.tar.gz to -srv-backup-etc.tar.gz at user storage. Wow, this is fascinating. So this is like really useful too, especially for like automation. So what it's asking is, now we're not in the lab anymore, but we could get back to the lab by doing SSH, and then we'll use a different username. Of course, we're going to use the username necessary to get into my lab. And now the IP, so we're using, instead of user at storage, we're using my username at the IP of my lab. And it's not working for some reason. What? Why is it not working? Maybe SSH works a little different. Let's try it in bash. Okay. I do not understand what is going on here. I feel like I'm at Jurassic Park right now, and all the gates are swinging open on the raptors and T-Rexes and all those. Okay, so that does not work the way I thought it would, which is good. Expecting something to happen and then that thing not happening is a good thing, because then you're like, especially if it's you're not expecting things not to blow up and then they blow up, like that's bad. But like, just learning how something actually works versus how you thought it works, that's good. All right, so I'm not sure what's going on there. I can get in if I do this lab command. What if I try SSHing the other way to my home lab here, or to my regular computer? Then it doesn't work. Okay, so let's use a GNS lab. So we'll use my, oh shoot, is that real? How do I, in Linux, how do I start a process such as GNS3 server as a daemon, so that whenever I close the shell, it persists and I don't have to keep running it every time I open a new shell?
Using nohub, and the nohub command can be used to run a command in the background and redirect its output to a file called nohub. Out. To run a process in the background and detach it from the terminal, append an ampersand into the end. 2. Using TMUX or screen mix and screen or terminal multiplexers that allow you to run multiple terminals inside a single terminal window. When you detach from a TMUX or screen session, any processes running within it will continue to run. For TMUX. For screen. 3. System service, recommended for long-term usage. For processes that you want to run automatically at boot and manage more formally, you can create a system service file. Create a new system service file. Add the following content to the service file.
Alright, I'm going to do that. I'm going to create a system service file for GNS3. I'm kind of surprised it's not on there already, but... Alright, there we go. And sorry, this is a tangent, but it's important for future future videos. Oops. How do I... Okay, there we go. Paste anyway, there we go. Then exits. Yes. There we go. So now I've got the file. So next is to... oh, nope, sorry, I gotta replace it with the username. Okay, so let's do that. Okay. Perfect. Got it. Okay. So then I need to reload system D and enable the service. Hopefully that won't be too difficult to do. Like cut off my remote access or anything like that. All right, and now I need to start the service. Perfect. All right, so now I won't have those same issues. It might even... Oh, you know what? Oh. You know what? That is a good thing. Yes. Okay, it did the thing that I've been wanting it to do. So, you know, very, very old version .17. We're already up to .40. But notice one thing about this message. The client version is at .17. The server version is at 1.4. So the server version is updated. That's the hard part. Updating the client version, super easy. So let's update the client version. I've been wanting to do this for so long. And unfortunately, it looks like it is at .42, but we'll try to get .40. Be nice if I could get .42. Perfect. This was amazing, and it had the added benefit of updating the version of GNS I was using on my server to 2.2.40.1. But the most up-to-date version is .42. How can I make sure that I am using the most up-to-date version on my server that I can?
Great. To hear that you found the information useful. Keeping your software up to date is essential, especially when you're preparing for something as critical as the NCORE Cisco exam. Here's how to update the GNS3 server to the latest version. Method 1. Using Packet Manager if you installed GNS3 using a packet manager like apt and Ubuntu, you can update it with the following commands. Method 2. Using Python pip if you installed GNS3 server using Python's pip packet manager, you can update it with. Method 3. Manual installation from source first, navigate to the GNS3 GitHub repository of the website where the source code is available. Download the latest release. Unpack the downloaded archive. Navigate into the unpacked folder and follow the installation instructions, usually provided in a README or install.
All right, let's try let's try the this is the method 3. Let's try the method 1. Hopefully this is super easy. There we go. There we go. Hopefully this gives us .42. I've been wanting to do this for so long. I've been wanting to do this before ChatGPT existed. And guess what? I wasn't able to do it then. I just couldn't figure it out. I can figure out how to update my client. Aha! So here we go. .42. That's what we're looking for. So, you know, as that's going, let's download this, and I'm gonna log into this. I've got an account already. Okay, and now we can get it. Next hop, I don't know what this is. Yeah, let's get it. Oh, this is that SolarWinds thing that they always want you to get a free trial for. No, I'm not interested. Oh, yes. I would like to uninstall. Oh, okay. I might lose all my labs, but I'm kind of at a point where I don't care. I can lose everything. There's nothing critical. There definitely was a point where that would be bad, but right now it's not so bad. Okay, so now we need to restart the GNS3 server, and we should be at 2.2.42 on the server. What command can I use to verify that I have updated GNS to the latest version?
This command will display the version number of your installed GNS3 server. You can then compare this version number with the latest version available on the official GNS3 website or GitHub repository to ensure you're up to date. Additionally, you can often find...
Damn. Why is it... See, this is like why I couldn't figure it out before GNS3, and I still can't figure it out. So, like... Why am I seeing two different versions depending on which command I use to look at the version?
Inversion numbers may occur for several reasons. Different installation methods. You might have installed GNS3 using more than one method.
Yeah, I did.
For instance, you may have installed it via apt and also via pip. Each could be pointing to different installation locations, leading to different versions.
Yeah, that happened.
Environment path. Your environment variables, $path, may contain multiple paths where executables can be located. One path might point to an older version, while another points to the updated version. Running instances. You might have an instance of GNS3 running already. Running GNS3 server version while a different version is in operation could yield varying results. User versus system installation. You might have a user-level installation and a system-level installation. They could have different versions. How to resolve. Identify installation locations. Use which a GNS3 server to list all the paths where GNS3 server exists. Bash copy code which a GNS3 server. Check versions. Run the version command on each executable path to compare. Bash copy code path to GNS3 server version. Remove old versions. Once you've identified any old versions, you can remove them to resolve the inconsistency. Bash copy code as sudo app remove GNS3 server hash if installed via app sudo pip3 uninstall GNS3 server hash if installed via pip reinstall. Finally, reinstall GNS3 to make sure you have the latest version. Bash copy code as sudo app install GNS3 server hash if using app pip3 install GNS3 server hash if using pip restart the service. If you are running GNS3 as a daemon, don't forget to restart it to apply the changes. Bash copy code as sudo system ctl restart GNS.
See how wonderful, like what a world we live in. This is insane. So yeah, so now we got to remove these old versions. So I'm not sure like where these came from. This is the one we're gonna keep. Then we're gonna remove these old ones. So okay, so I'm sure I installed one using pip. In any case, we just saw that I installed it using apt. So like, you know, if there is one installed using pip, we don't need it. So like, yeah, here it is. We uninstalled version 17. So now with the witch-a, now here, we still have another one. Is there like a let me try this. GNS3 server / help or like -h for help. Or like man GNS3 server. I don't think that's gonna work. Okay, so how do I know what I need to do to uninstall this one? Because this one is version 17. This one's actually version 18. That's weird. So we've got the GNS3 server here. And it's not a directory, it's an executable. Um, oh, you know what? We can just uninstall all of them. That's kind of the brute force way. And as I said, I don't care that much if I lose all my apps lab stuff right now. I'm kind of in between. I guess I kind of care if I lose my Juniper images, because like it's hard to find that. I actually kind of care a lot if I lose my Juniper images. Shoot. No, I care a lot if I lose my Juniper images. Oh, this is such a disaster. This is why I just don't touch this. It's like, it's working, so I want to keep it working. I don't care if it runs on version 1 and it's 30 years old. Like, if I could do what I need to do using a 30-year-old piece of software, and I can't do what I need to do using a modern piece of software, guess which piece of software I'm going to use. Shoot. Oh, what a disaster. I'm going to lose all my images. Oh, my God. Losing those images is like a really big deal, because I'm not going to be able to get them back. Oh, my God. I'm hurting on the inside. I'm hurting a lot on the inside. Alright, so let's keep going. So, oh man, this is horrible. Oh, I knew not to screw with this. Just, if it's working, just stand back, don't mess with it. Oh man, I poked the bear. I did this to myself. I should not have done this. Oh my God, this is a disaster. This is such a disaster. Oh, this is so bad. Oh my God. See, now we're gonna, let's see what version we're gonna remove. Doesn't say. Oh, what a disaster. Oh, it's removing .42. Thanks for telling me after I decided to remove it. Okay, now we've just got this one left. Oh, this is such a disaster. Okay, so now I don't. Oh, I still have it. Oh my God. Oh, it doesn't have a dash. What the heck? What the heck? I'm so confused. Is this like all my images and stuff? It's not a directory. Why can't I remove this one? It doesn't even exist. Oh, why is it still there? See, this is the thing, like, yeah. I mean, residual files are good. If the residual files are like all my images and stuff, I want residual files. So I guess I'm just gonna try it again. This is seriously like one of the worst things that's happened to me in a while. Because I'm gonna lose all my images. Like this is like, this is an absolute unequivocal disaster. Like everything is gone. Like those images aren't easy to get. Okay, I'm running 4.2 now locally. So I've got to get 4.2 on here. Oh my god, what happened? Okay, and then we need to restart the daemon. Okay, and now the daemon should be live, so yay! Oh my god. Happy days are here. So not only do I still have all my projects, and are they all loading, probably because I did not delete that residual file, I've also got all my images. Oh my god. Okay, so and I think I'm gonna see if they actually boot up. That's a kind of an important aspect. Oh my god. Hey, I just gotta say, as scared as I was, I am happy now because I'm running the latest version and I preserved all my projects and all my images. Like, I've been trying to do that for like years. And thanks to ChatGPT, I did it in minutes. Alright, so let's open one more project. We'll open the David Bumble lab. We'll start everything up. Hopefully things will work like faster now too, because there'll be some bug fixes and stuff. You can see that should have bought more CPU and less RAM. Don't make the same mistake I did. I didn't completely make a mistake because I actually thought about buying more RAM than I did. But the costs of the server would have increased quite a bit. I think they actually increase a bit more with RAM than they do with CPU. I'm not sure. All right, so we got a command prompt. Happy with that. So yep, I want to close it. Do I want to stop all the devices? Not yet. Let's just make a new one. Untitled. Sounds good to me. And then, yeah, I just want to make a, I just want to explore the, really simple, the SSH command. And this always takes longer than you'd think it would. All right, so what I just want to play with this here. So, oh, and we're actually on. Hey, happy days are upon us. We're on the final question before the summary, and whoa, we're at the 1:30 mark. Oh my god, that's not good. Aha, so here we're at the GUI for both of these machines. Gotta type in the password correctly. Okay, so now we're gonna need to configure the network settings. So configure basic point-to-point static network connectivity between two Ubuntu version 20 servers. This is so good. What a world we live in. Seriously. This is absolutely insane. Yeah, here's the first file, and then they'll give me a second file. Oh, they're not going to give me the second file. I just have to put that in myself. Alright, well, I mean, that's fine. Look at how crazy this is, though. Like, it just makes it so much easier. Oh, right. Well, I guess not that much easier because my clipboard doesn't persist. But I could get internet to this and do it all local to that. But let's not do that. Okay, so we're gonna do sudo nano tc net plan, and then yep, there we go. Okay, and then I'm gonna add in shoot, and I can't put this in there. Whatever happened to like IP, like, can't you just set it up with IP? Yeah. Okay, well, they'll be lost on reboot, but I don't care about that. Okay, so let's bring down the okay, so we're gonna bring down the interface first. Okay, and then we're gonna assign a static IP address. Oh, we can't find so what if I do okay, we'll do it for ENS3. Okay, then sudo IP add 68.1. We'll do that .1.1 for this one. Dev ENS3. Okay, now we gotta bring we'll bring it up once the other one's configured. Okay, so now open up the terminal. There we go. Okay, so this is going to be ENS3 as well. So do IP dev ENS3 down. There we go. And then sudo IP ADDR. So this is the quick and easy way, but this way doesn't persist after a reboot. So not the best way in production. I must have misspelled something. Oh, yeah, I did. I left off dev. There we go. Okay, and then now we can bring up the interfaces. So bring up this one first. Dev ENS0 up. ENS3 up. There we go. And now on the other one. Okay, so now let's test the connectivity. And there we go. That I can ping across the wire. I can ping myself. Everything is hunky dory. So now let's do 192.168.1.2 and make sure that SSH works. And it kind of does. Okay, yeah, it does. So let me ask you one more thing. What can I do to make it so that when I SSH to the other server, I no longer need to pass the password to it, and it's just automatically authenticated because it knows the key?
Setting up SSH key. Based authentication is an excellent way to secure your server connections and automate logging in. Mastering SSH and its intricacies can definitely be beneficial for both your job interview and the NCORE Cisco exam. Here's how to set up SSH keys for passwordless authentication between two Ubuntu 20.04 servers. Step 1. Generate SSH keys on the client if you haven't already. Generate an SSH key pair on the client machine, the one you'll be SSing from. This will ask where to save the key. By default, it saves the key to tilde. SSH 8_RSA for your user. Press enter to accept the default.
Yeah, so we don't have a key yet, so that's why it wouldn't work. First thing we need to do is create a key or generate a key through the command ssh-keygen. And then we want just an RSA key. We don't want to blow up the machine with key after key after key. We just want the one key that we need. There we go. And we need to do that on both devices. Okay, there we go. Oh, yep, we want to just do all the default stuff. We gotta do all the default stuff on this side as well. Ooh, now it already existed. Yeah, let's overwrite it. Sounds good to me. Okay, did we have to overwrite on this one? We didn't have to overwrite on this one, so I'm not sure what happened here, but apparently there was already one. But that's okay, we can overwrite it. This is now in production you wouldn't want to do that because you'd tank all the connections. You'd have to run this command again on all your devices, which would be not so good. But we're just in the lab here. Yep. Yeah, so this is the, oh, sorry, never mind. This is the machine at that too. God damn it. Okay, so now I can do SSH GNS3 at 192.168.1.1, and I'm .2. There we go. So how do I change the bash prompt so that I can tell that which machine I am logged into via SSH and I don't get the machines mixed up?
Changing your bash prompt to clearly indicate which machine you logged into is a smart move. This is especially useful for avoiding mistakes while working on multiple servers, something you'll undoubtedly find handy both in your job scenarios and in real-world applications.
Okay, so here's what we can do. Yeah, this is for like bash RC. We'll just do this. So Yeah, that's for having it persist. Um, so we're just going to have it be temporary. Okay, so for a temporary change, which will be lost when the session ends. Oh, this is just when the session ends. So this is like once you're in. So that's not going to be good. Yeah, I think this is more what we want. We want it to tell when we're in a yeah, so like so like we could say like it means like yeah, this is really good. So let's set this up. So we're going to do vi bat dot bash rc. There we go. And now we add this to the end. Okay, I'm in insert mode. And we're going to say change CLI prompt for SSH connections. Okay, I'm going to do if -n h client or -h and SSH connection. Then, and I assume we need like a extra character. Nope. Okay, so PS1 equals so username. Okay, so _u, and then host name, and then SSH, and then -w this, like that. There we go. That looks good to me. And then and then else PS1 equals /u at HW S. There we go. And then okay, so now we need to enable that. We need to apply the changes. So source etc bash.bash rc, applying the changes for all users. Oh, and I did it. Oh, I did it on the remote machine. That's weird. So maybe it just does it. Maybe it's I think it's for outgoing connections. So it's like. Oh, and I have to do the learning of the key here, I think. Oh, let me just try it. We'll do IPA to see which one I'm on. So I'm on the .2. So here's the .1. Yep, so we made it over to the .1, and we don't see any of those changes. But it is good to know that we don't have the oh. And it looks like we had a connection to ourselves. Let's see which one I'm at. All right, I'm on the .1, so let's go over to the .2. Oh, now this is interesting. We need a password. So we're not cool with that, so let's do it by the SSH key. Oh, okay. Well, then let's create an SSH key, I guess. Okay, and then we'll try this again. Yes, we would like to do that, please. There we go. Okay, and now we can get in here without a password. But we still don't have that change. Let's see if we can get on the other way. Now that we created a new... Oh, here it is, here it is. So we don't have that change because the syntax is screwed up. So something happened where I just didn't type in the right syntax. I probably forgot like an escape character. Something happened. But we can see it's a fat finger. I typed something in incorrectly. So that's not a big deal. Really what we're trying to look at is this explorational exercise anyway. So now that we have a lab to work in, let's work from the .1 device. And we know that we're on a remote machine because of the coloration. So this is the .2 device that was connected to the .1. So let's go on the .1 device and let's connect to the .2. There we go. And then we'll exit from it right away. And now we'll work on the explorational exercise. So the explorational exercise is given that SSH also allows to redirect the standard output of a local program to the standard input of a remote program. How would the cat command pipe a local file named that? So let's create that local file. We're going to say, we're going to echo hello world. And then the output is going to be redirected from the screen to a local file named etc.tar. Let's just call it hello.txt. Just make it easier. So here's hello.txt, catting it out. There we go. There's a standard output of hello.txt. So we're doing the same thing. We're just not dealing with complicated file types, just simplifying things, which is always a great thing to do when learning. So now what we're going to do is go back to that SSH command, which you can see still works here. And we're going to now pass it, so in between these quotes, now we're going to give it a remote command. So what we want to do is use the cat command, and then what we want to do is pipe a local file to a remote file. So let's get the remote file going. So we're gonna do so the local file is hello world. So the remote file is going to be echo let's do echo space world and redirect that to hello.txt. Okay, and now we'll cat hello. So there we go, and then the actual file is hello world. So we'll do that. Cat hello. There we go. That's the full file. So now if we want to go here and what we want to do is overwrite the hello.txt on the other machine, so that when we go to the other machine and we cat it out, now it's the full hello world, and we want to do that by redirecting the standard output of a local program. So the local program we're going to use is cat, and then we're going to redirect the standard output of this. So we're going to cat, and we're going to cat a local file. I'm not exactly sure how to do that. Let's try it just by doing the hello.txt like that, and then so we're going to cat the okay. Okay, and then we're gonna. How would the cat command pipe a local file to so let's just try it. Cat hello world pipe or let's just redirect it. Hello.txt. Let's try it. Okay, so now let's do cat hello.txt. Okay, same thing as expected. And now let's do a cat hello.txt here. Okay, so this is interesting. We've actually now deleted what was in there. So let's set it back to normal. Okay, and then we'll try something else because that obviously was not the right answer. So I guess what we could try is like a colon. So we could do like a cat colon backslash or colon home backslash hello.txt. Does that work? Maybe forward slash. Nope, that does not work. Okay, so this is a tricky one. This is very, very tricky. Okay, so part of the answer is going to be it's going to be definitely the SSH and then something wrapped in quotes. But I'm not sure what to wrap in quotes. Oh, you know what? This is how you do it. So this is standard input. Yeah, this is how this works. So let's use a command like WC again. And let's see what happens. So what happens is it hangs, and then it takes standard input, the keystrokes from my computer. Now let's run, or it can take the contents of a file. So this hello.txt, there we go. So if you don't feed it a file, it takes standard input, which comes from your keyboard, your keystrokes. But if you do feed it a file, then it will just take the input from the file. It's not the standard input. It's just the contents of a file fed to it as input. So we can think of it the same way for SSH. If we don't give SSH a file, so we just do the basic SSH command here, SSH the username, and then the IP of the other system. It's doing the same thing that WC did. It's waiting for input from the keyboard. It's taking standard input from the the remote machine. Pretty cool, huh? So now we can do the same thing that we did with the WC command, where we feed it a file, where we feed it input in a different way, not from the standard input. So what we can do is we can feed it input like this. So we need this cat command on the other side, because what we're going to do is we're going to cat hello .txt, and then we're going to in quotes. So the standard output of hello.txt is converted to input and then fed to this command as input. So I believe we need the t command. I think we need the t command. Yeah, and it's not I have to open the terminal again. I was not in a, and I should have been able to know that from the coloration. But I think if you want to so like let's do this. So we've got the hello file that's still good to go. Looks good. So let's do make directory testing. There we go. And now we're going to go here and we're going to try to put it in the testing instead. So we're going to do, so t testing sudo terminal. So yep, we went in and then we went out. It said something about a sudo terminal. I'm not sure what it was trying to say. But now we can do the cat. Oh, and we still got the world. But if we go into testing, still got nothing. Okay, so I wonder if the t command is even necessary. So let's try it again, but let's leave out this t command because we're piping this into standard input. And it's a pseudo terminal, so we're no longer taking keystrokes from that remote machine because we're no longer taking standard input. We're taking input from the result of the left side of the pipe. So now if we do cat hello, oh, we still got the same thing. Yeah, but the command cat takes standard input. So this is how you do it. You say here, and then in quotes, what do we want to run? We want to run cat, which takes standard input. So the standard input will come from here. So this is my final answer. There we go. And we get back hello world. So, but the thing is, you know, we don't want that. So how would the cat command pipe a local file and save it as you know the file name? Well, you could also do it like this. T. So now we got the same thing. We have the standard output, but now the standard input, which is the converted output of this file, is saved to the file. So we will see now this, instead of saying world, we will see it say hello world now. I'm puking. Sorry. Okay. Well, that didn't work the way I thought it would. Okay. Why didn't that work the way I thought it would? Maybe I'm not in the right. No, I am in the. I was thinking like maybe I was looking at the wrong file. But I'll just remove that just to keep things simple. Okay, so it didn't succeed in that way. So I don't think it's T. I think what a good thing would be echo. Wait, but echo doesn't take standard input. So I definitely need something that takes standard input. Um, and we know that cat takes standard input. So yeah, you know what? Let's do cat, and we're gonna do redirect that standard input into hello.txt. And now we don't get back anything because it was redirected, and we go to the other device, and there we go. Now we've got the expected result. So let's see what the official answer is. Aha! So the official answer is exactly what I did. I just thought through it, and in thinking through it, I came up with the right answer. It's funny how that works sometimes. It's funny how that doesn't work at other times, but in this case it works. So I'll give a little golf clap. All right, and that's the end of the explorational exercises. So now I just need to read the summary, and that will be the end of this video. So the summary is: this lesson covers traditional inter-process communication techniques deployed by Linux. So that's why the standard output is so important to learn about and understand. It's because like when we're on remote systems, the remote system is receiving the standard output and the standard input, and the standard error is so important to understand, because when we're on a remote system, what are we even sending to a remote system? Are we sending an input? Are we sending an output? You have to know that. So like when you just create a regular session, why does the system know to just hang and wait for you to type in stuff? Well, because it's receiving your keystrokes, it's receiving standard input. So, that's another thing you can do for security, is like you can disable the system from receiving standard input. So like somebody can't just hang on the system and send keystrokes. The system is so secure that you can only send authorized files that match the checksums. So like, yeah, this is good stuff to know. So command pipelining creates a one-way communication channel between two process, and command substitution allows to store the output of a process in a shell variable. The lesson goes through the following steps: how pipes can be used to stream the output of a process to the input of another process, the purpose of commands like T and xargs. The purpose of the command T is to take the input and save it to a file, and then to also display the output. If you don't use T, then you lose that input. Typically, it's not saved anywhere. And then the purpose of xargs is to feed is to run a command multiple times with different arguments each time, and you use the command xargs kind of like you would use an f string in Python. You create a variable relevant to the xargs that is used for the input, and then you tell the command you're using where to accept that variable. So like, for example, if you did cat file.txt, the file contained a bunch of file names, you would do pipe xargs dash uppercase I file names, and then if you wanted to cat out those file names, you do cat file names, and then hit that, and then for each of the file names in that file, it will print them out. So then we learned about how to capture the output of a process with command substitution, storing it in a variable or using it directly as a parameter to another command. And the way you do that is you convert the output to the input, and by doing that you can store it. You can use that with two backticks or with $ open close paren. The commands and procedures addressed were command pipelining with the pipe symbol, command substitution with backticks and $ open close paren, and the commands T, xargs, and find. All right, so that's it for this video. I hope everyone had the same kind of aha revolutionary moments that I've had really feel like I understand the STD in, STD out, and STD ERR. I've always, struggled to understand that. I've always, when learning Python, kind of glazed over my eyes and moved on because it just was not clicking at all. But it clicks now, and it's important, especially with interactions with remote machines and with like understanding where a program gets the parameters you want to pass it. So like it's important stuff, and hey, I finally learned it. So thanks for watching, and stay tuned for the next one.